Welcome to Nanoindenter training. In this session, we'll be talking about how to analyze your data. So to get started, let's open up the Data Viewer software. When the software opens, it automatically opens to whatever the last person was working on. So that's what these curves are that are showing up automatically. Let me take just a minute to walk you through the different sections of the software. This section up at the top is kind of how we select the data that we're viewing currently. Down in the bottom, we have two tabs, a stage tab and an indentation tab. I'll talk about both of those in a minute. We have individual force curves here, and this is currently our displacement versus time data that you saw in the data collection software. And we can change what is being displayed in either of these top two windows. I'll talk a little bit more about that later. So let's go ahead and get started. The first thing to do is to load some data. So click on this folder to do that. Now, this is the folder I want to look at. Yes. So this is where I want to be when I select folder. A common mistake is to go ahead and select one of the matrix scan folders. And when you select that, it's going to give you an error message saying that no experimental files are found, and select a different folder. And so all we have to do here is go up one level. So I'm going to come back to this folder and select it. And now what you'll see is that I have the choice of those 4 different matrix scans. And actually, I want to look at number 4, so I'm going to load that one. And you'll see it preview all of the data as it's essentially fitting it all. This is a great way just to get a look at the data, make sure there's no obvious things that are wrong with any of the curves. If there are, you can go back and manually remove them from your matrix scan. But this data looks great. The particular curve that we're looking at right here is this one. So this is a 5x5 matrix. And so this is X1, Y1. And if I click on this pull down, you'll see there's X1, Y2, X1, Y3, until we get to X2, Y1, and so on, all the way down to X5, Y5. So I can select any one of those that I want to look at, and it's going to pull it up into the data viewer. Now, what we're seeing here is that the light blue curve is the approach curve, or it's called the loading curve here. There's a very short hold step of 0.1 second, and you can see in the dark blue right at the top, that's that hold step. And then in green is the unloading curve, or the retract portion of the curve. The red is then the fit to that data, and we are fitting the loading portion of the curve. And so we want to make sure that the red matches the light blue fairly well. So we can scroll through these curves, and as we do, we see the different data being displayed. And we also see down here the particular stage position. So it's telling me this is X5, Y5, which matches with what we see up here. And it calls position 1, 1, X equals 0, Y equals 0. So you can see that we have now moved to 400 by 400 in terms of its XY coordinates. Most of the time, however, when I am in the software, I spend my time in the indentation tab, because this is where I see Young's modulus. So you can see that this particular sample has a Young's modulus of 4.47. If I go to the next sample, 4.6, 4.48, pretty consistent. So I want to show you also how to look at this data in a slightly different way. This is individual curves for individual force curves, but we can also look at either a 3D plot, which you can click and move to kind of drag it around. Now, this sample was supposed to be a fairly homogeneous sample, so this is not so useful for me. But the histogram is fairly useful because it shows me kind of the spread of my Young's modulus values. Within this histogram, we can change the number of bins, for example, if we want to make sure that we're really capturing all of the data. Now, So far, the software has been working great. It's fitting this data really well, but you may want to tweak some of the conditions. You may want to fit less of your curve or more of your curve. And so in this options tab are some ways that you can control that. At the top, it gives you the parameters for the probe that was used to take the data. So this is saved with the force curve when you acquire the data. You're not allowed to change this after the fact. And then this middle section is asking us how we want to fit the data. And most commonly, we use a Hertzian model. And when we do that, we can then select the percentage of the curve we want to fit. So maybe in this case, I only want to try to fit 50% of the curve. And then finally at the bottom, the software is asking us for the Poisson ratio of the sample because that's used in the calculations to extract the Young's modulus. Now, Poisson ratios usually vary from about 0.2 to 0.5, and they're very commonly assumed to be about 0.5 for biological samples. You probably don't know the Poisson ratio for your sample. And in many cases, people will assume that their Poisson ratio is 0.5 and then make sure they include that in the experimental section of their paper. So let's go ahead and save this. And you can see now that the amount of the curve has changed. And if I scroll through a few more of these, you'll see that they're all only fitting about half of the curve. So it's a very easy way for you to adjust that. And as we do that, it is updating this histogram as well with those slightly changed values. Actually, let's take a quick look at that. So here's our Young's modulus, 4.54. And what happens if I change that to 99% of the curve? How much does that change? 4.43. So there is a little bit of a variation when you change the amount of curve that you fit. So you want to try to be as consistent as possible, especially within the data for a particular data set where you're trying to make comparisons between samples. So you can see that the software is fairly simple to use and fairly intuitive. But if you do have questions, please jot them down, and I would be happy to talk with you about them when we do our live session.